3 red LEDs for each player and 1 green LED for the indicator. 220 resistors per LED. 4 push buttons, 3 for each player and 1 for the reset button. And here is the complete list of materials that we're going to use for this program. And here is the circuit diagram of this system. Each player has their own push button wired to a separate digital input pin on the Arduino. When a player presses their button, the Arduino detects that signal. Every button is paired with its own LED indicator. When the player buzzes and bursts, their corresponding LED lights up and the buzzer on the far right activates to signal that a winner has been registered. The system includes a reset button connected to another input pin. Pressing it clears the previous result, turns off all LEDs, and re-enables all player buttons so the next round can begin. So we will proceed to the explanation of our code for this specific task sheets, which is the controlled multiplayer quiz buzzer. So on the first 4 lines of our code, we have here is the assignation of pins for LEDs. So on LED 1, I use pin 6, which is digital. For LED 2, pin 5, LED 3, for 4, LED 4 for pin 3. And 2, 6 to 7, and 8, I assign buttons for each player. Button 1 for player 1, I assign it to analog 0 pin. Player 2, button 2, I assign it to analog 1. Button 3, for player 3, I assign it to analog 2. And for the reset button, I use analog pin number 3. And here, as you can see the buzzer, I use digital pin number 8. After that, I create a variable called winner locked, which tells the program if someone has already pressed their button first. And inside the setup section, I set all LEDs and buzzer into output or as outputs. Here, all buttons are set as input pull-ups, so they stay high until someone presses 1. I also set the starting point for all player LEDs are off, as you can see here, and the red light or the green light LED 4 is on. Now the loop begins. The first thing the program checks is the reset button, this one. If it is pressed, the winner status resets. All player LEDs turn off. The red light comes back on. As you can see here, the player LEDs are off and the red light, which is the LED 4, are high. It also stops the buzzer and the loop restarts after a short pause, which is the 1000 milliseconds or 1000 or 1 seconds. The next line checks if someone already won, which is this one. If winner lock returned. If winner is locked in, the loop skips everything else until the reset button is used. After that, the program waits for the first player to press a button. This one. If player 1 presses theirs, The LED one will turn high or turn up, and the ready button or the ready LED will turn off, and a short beeps play for the buzzer. And the code locks the winner, which is the player 1, if he or she was the first one to presses the button, who presses the button. And the same pattern happens for player 2 and player 3 using their own LED, which is this one. As you can see here, if button 2 is pressed, LED button or LED2 will go off or go high, the ready button will turn low or off, and a short beeps play. And of course, the code blocks the winner, as you can see here. The same goes happen for player 3. Once someone wins, nothing else responds until the reset button is set, or until the reset button is pressed. This keeps the game fair by making sure only the first button press counts.
As for task demonstration for our sample rounds, when I press the player 1 button, the red LED turns on, and when I press the player 2 and player 3 buttons, it won't turn on. But when I press the reset button, it turns up the LED of the player 1, meaning the system is already accepting for a new winner. We ran into challenges with the wiring because the circuit became messy as we added more components. The layout of our initial design made it hard to keep everything organized, and this became a problem when we tried to include a ready indicator. Since the original circuit didn't have space for that feature, we had to revise and rebuild the setup. After getting advice from Miss Alpi, we adjusted the wiring and redesigned the circuit so everything could fit properly and work the way it should. It took extra time, but it helped us create a cleaner and more reliable system for our final demonstration.
Realize this system has a lot of real-world use. It can be applied to actual quiz bows, competitions, or even classroom activities where fast and fair answer is needed. The design can still be improved by making the casing more durable, adding a display for scores, or upgrading the sensors to handle more players. Working on this project helped us see how electronic and teamwork can come together to solve practical problems, and how small improvements can make the system even more reliable for real events. I learned that digital input-output interfacing is all about making sensors, buttons, and indicators communicate clearly with the microcontroller. It showed me how important clean wiring and proper pin assignments are because even small mistakes can affect how the whole system responds. I also understood priority logic better on how the circuit decides which input should be read when multiple players try to answer at the same time. Seeing it work in action made the idea easier to understand.